Fingerprints, tiny ridges on our fingers, yet one of the most powerful tools in forensic science. From crime scenes to courtrooms, fingerprint analysis plays a crucial role in solving mysteries. But how do forensic experts collect, analyze, and match fingerprints? Hello guys, welcome back to the channel Case 23, where we decode forensic science. So today in this video, we will explore the fascinating world of fingerprint evidences, also its types, collection techniques, and the technology behind forensic identification. So stay tuned as we uncover how a single fingerprint can crack a case wide open. So let's get started. Before we begin, let's take a quick look at what we will cover in this video. First, we will start with an introduction to fingerprint evidence and why it is so important in forensic investigations. Next, we will look at the types of fingerprints and how they are collected from crime scenes. Then we will talk about minutiae patterns and the tiny details that make each fingerprint unique. After that, we will move on to classification, where we will break down the main fingerprint patterns. We will then move on to the main part of the video, that is fingerprint analysis and examination, where we will learn how experts compare and verify fingerprints. And then finally, we will explore one of the most fascinating parts of fingerprint forensics, that is, recovering fingerprints from the dead bodies. This process comes with many challenges. What happens when a body is burned in a fire? What if rigor mortis makes the finger too stiff to move? Or what if the fingers are damaged or decomposed? Don't worry, in this video we will answer all these questions, so stay with us as we reveal the hidden secrets of the fingerprints. So our first topic is introduction to fingerprints. But before we dive in, let me ask you some questions. So what are fingerprints? Also, have you ever looked closely at your fingertips? Those tiny ridges and grooves? Well, those tiny ridges and grooves are not just for grip, but also they tell your unique story. And how? So the answer to that is fingerprints are made of friction ridges, the raised parts, and furrows, the recessed parts, forming patterns that are one of a kind. They stay with you for life. That's right. Even if you grow up, age, or even get minor cuts, your fingerprints remain unchanged. And here's something mind-blowing. No two people on Earth, not even identical twins, have the same fingerprints. That's why they are so invaluable tool in forensic science, helping experts crack cases with absolute certainty. So let's talk about the history of fingerprints. Imagine a time before ID cards or before passports. How do people prove who they were? Well, ancient Babylonians had a clever trick. They pressed their fingerprints onto clay tablets as signatures for the business transactions. And over in China, officials used fingerprints to authenticate documents over 1,000 years ago. But it was not until the 19th century that science caught up with ancient wisdom. J.C.A. Mayer was the first to recognize that no two fingerprints are alike. Not even identical twins share the same fingerprints. Then came Dr. Henry Falls, who suggested using fingerprints to catch criminals. Imagine a crime scene in the 1800s. No DNA test, no surveillance cameras, just fingerprints left behind as silent witnesses. Imagine the situation of those forensic experts. Now, in 1897, Sir Edward Henry revolutionized the system by creating the Henry classification system, making it possible to catalog and search fingerprints efficiently. This changed law enforcement forever. By the early 20th century, fingerprinting became the gold standard for criminal investigations. Then came the digital age. Automated fingerprint identification system, also known as AFIS, transformed how fingerprints are stored and analyzed. Today, police can match a suspect's fingerprint in a database within seconds, something that would have taken days or even weeks in the past. From ancient clay tablets to high-tech crime solving, fingerprints have always been a powerful tool of identity. Alright, let's talk about why fingerprints are such a big deal in forensic science. You might be wondering, out of all the things we could have used to identify someone, why fingerprints? First up, they are unique. No two people on this planet, not even identical twins, have the same fingerprint patterns. Think about that. You could have a twin who looks exactly like you, but your fingerprints completely different. That's why fingerprints are so powerful in criminal investigations. If a suspect's print is found at a crime scene, there's no denying they were there. Second, they are permanent. Your fingerprints don't change throughout your life. Unlike your face, which wrinkles, or your voice, which can get deepened or weakened, your fingerprints stay the same from the day you were born until the day you die. Even if you get a cut or a burn, the ridges tend to grow back in the same pattern. That's why forensic experts can rely on them for cases even decades old. Third, they are universal. Every single person has fingerprints, no matter where they are from, making them a global forensic tool. Whether it's a high security airport in the US, a government office in India, or a police station in London, fingerprint analysis is used wherever to confirm identities. Next up, they are classifiable. Imagine trying to find one fingerprint among millions. Sounds impossible, right? But thanks to classification systems like the Henry system, forensic experts can systematically organize and retrieve fingerprints within seconds. It's like having a well-organized library where every book, or in this case, fingerprint, has a unique place on the shelf. Then we have the fact that fingerprints are frequently available in crime scenes. Criminals unknowingly leave behind silent witnesses, their fingerprints, on surfaces like glass, doorknobs, or even weapons. A single print can place a suspect at the crime scene, providing crucial evidence that helps investigators crack cases wide open. And finally, fingerprints are inimitable. Unlike fake IDs or disguises, you can't forge a fingerprint. The intricate ridge patterns are so detailed that even the most advanced criminals can't successfully alter or replicate them without getting caught. That's why they are used in high security systems from bank vaults to airport immigration checkpoints. So whether it's catching criminals, securing data, or providing identities, fingerprint remains one of the most powerful tools in forensic science. As Sir Francis Galton, a pioneer in fingerprint analysis, once said, the importance of fingerprints in criminal investigation is that they never change or they never lie. And that's exactly what makes them one of the most powerful tools in forensic science. Then the next topic is types and collection of fingerprints. So let's talk about fingerprints. Not all fingerprints are the same, and depending on how they are left behind, they are basically categorized into three types: latent, patent, and plastic. Let me break it down for you. First will be the latent prints. They are the hidden ones. You can't see them with your naked eyes because they are just sweat and oil left behind on a surface. But don't worry, special techniques like dusting or UV light can make them visible. Here the example would be the fingerprints on your phone screen or a doorknob. Yep, they are latent prints. Then there are patent prints. These ones are easy to spot. They are made when fingerprints have something like blood, ink, or grease on them. Touch a piece of paper with an ink-covered finger, and boom, that's our patent prints. The last ones are plastic prints. They are 3D prints. If you press your finger onto something soft like wax, butter, or wet paints, your fingerprint leaves a deep impression. Ever seen your fingerprint in wet clay? That's plastic prints. So whether they're hidden, visible, or three-dimensional, fingerprints are everywhere. So these are some of the images of latent, patent, and plastic prints. Alright, let's talk about one of the coolest ways to reveal hidden fingerprints, the powder method. This is like forensic magic, where we make invisible prints appear using special powders. But not all powders work the same way. Let me show you how. The first one is black powder. This is the classical choice. It's made of carbon or graphite and works best in light colored surfaces because it creates a sharp contrast. Think of it like using a black marker on a white paper, super clear and easy to see. Then there is white powder. Now what if the surface is dark? That's where the white powder comes in. It's usually made of titanium dioxide and does the opposite of black powder, making prints pop on darker surfaces. And then there are fluorescent powders. Here's where things get really cool. On colorful or patterned surfaces, normal powders might not work well. That's where forensic experts use fluorescent powders, which glow under UV light. Imagine shining a flashlight in the dark and suddenly seeing fingerprints appear. Pretty awesome, right? And then the last type of powders are magnetic powder. Ever heard of a powder you don't even have to touch? That's magnetic powder. It's applied with a magnetic wand, which helps prevent smudging. But heads up, it doesn't work on metal surfaces or anything magnetic because it could mess up with data stored on devices. Once we have developed a fingerprint, we carefully lift it using adhesive tape or gel lifters and send it for analysis. Till now, we have discussed the physical method or powder method to develop fingerprints. Now let's dive into chemical methods for developing latent fingerprints. Sometimes regular powder methods don't just cut it, especially on surfaces like paper, fabric, or cardboard. That's where chemical methods comes in, reacting with fingerprint residues to make them visible. Let's check some of the most commonly used ones. First up, ninhydrin. This is a go-to method for porous surfaces like paper and cardboard. It works by reacting with amino acids left behind in the sweat, turning the print a deep purple-blue color. This reaction is called Ruhmann's purple. This process is simple. Forensic experts either spray or dip the paper in an ninhydrin solution, and then they apply heat or humidity to develop the print. Next is silver nitrate. This method is a lifesaver when other techniques fail. It reacts with the salts in sweat, forming silver chloride, which darkens when exposed to UV light. The prints don't just show up immediately. They need to be developed under a strong light source. It's specially used for old or faded fingerprints on porous surfaces. And finally, iodine fuming. This technique works best on semi-porous materials like paper and fabric. Instead of a liquid, iodine crystals are heated in a chamber, releasing vapors that interact with fingerprint residues. The result? A temporary brown print that appears like magic. And here's the catch. It fades quickly, so the forensic scientist must either photograph it immediately or fix it with a touch solution. So whether it's sweat, salts, or amino acids, these chemicals help forensic experts reveal hidden fingerprints where other methods fail. Science truly brings invisible evidence to life. Till now, we have focused on latent fingerprints, the ones that are invisible to the naked eye and need special techniques to develop. But what about patent and plastic fingerprints? These are prints that are already visible. Forensic experts used specialized methods to document and preserve them without altering the details. So let's check out how that is done. First up, photography. This is the most crucial step. Before doing anything else, high-resolution photographs are taken to ensure that fingerprint is accurately recorded in its original state. This is especially important for fragile or temporary prints because once they are disturbed, they are gone for good. Next, we have lifting techniques. Tape lifting is a common method used for smooth surfaces like glass or tiles, while gel lifters are preferred for rough or textured surfaces where additional tape might not work. These techniques allow forensic experts to extract and preserve the fingerprint for further comparison. And then there is the laser technique. This is where technology takes fingerprint analysis to the next level. Lasers can make fingerprint residues fluorescence or glow, making them easier to visualize on multicolor or complex backgrounds. The best part? It eliminates the need for chemical treatments, ensuring that the print remains untouched and perfectly preserved. So now that we know how fingerprints are developed, let's talk about what actually makes them unique. They are minutiae patterns. Minutiae are the tiny ridge characteristics in fingerprint that help forensic experts identify individuals. These patterns are like hidden codes in our fingerprints, making each one different from the rest. Now let's go through some of the key minutiae types. First one is core. This is the central part of the fingerprint, especially in loops and holes. It's like the heart of the pattern and is used as a reference for classification. Then there is the delta. This is the triangular shaped ridge pattern usually found in loop and hole fingerprints. It looks like the Greek letter delta and serves as the important reference point in fingerprint classification. Ridge ending. This is where a ridge suddenly stops. Imagine drawing a line and just lifting your pen midway. That's a ridge ending. They are crucial for fingerprint identification. Lake or enclosure. A ridge that forms an enclosed loop, making a small oval or circular shape, kind of like a tiny pond in the middle of your fingerprint. And then there is return. This is when a ridge makes a U-turn and curves back in the direction it came from, forming a sharp bend. Bifurcation. This happens when a single ridge splits into two, like a fork in the road. Bifurcations are one of the most commonly used minutiae for fingerprint matching. Trifurcation. Similar to bifurcation, but instead of splitting into two, the ridge splits into three branches, just like a tree trunk dividing into three main branches. Spur or hook. A short ridge that branches off from a longer ridge but does not fully split, kind of like a tiny hook attached to a line. Island or dot. A tiny ridge that is completely isolated, like a small island in the middle of the ocean. These are rare but very useful in forensic analysis. Crossover. This occurs when two ridges intersect, forming an X shape. Have you noticed how many minutiae patterns I've included? That's right, 10. And there's a reason for that. In forensic science, for a fingerprint match to be legally valid, at least 8 to 10 minutiae points must be identical between two prints. This ensures accuracy, reliability, and uniqueness in the identification. But here's the cool part. Modern automated fingerprint identification systems, AFIS, go way beyond just 8 or 10 points. These systems scan and compare dozens, sometimes even hundreds of minutiae points to make sure there is no room of error. The more matching minutiae points, the stronger the evidence, making fingerprint identification one of the most foolproof forensic tools out there. Alright, now that we have covered minutiae patterns, let's put our observation skills to the test. Take a look at this fingerprint image on the screen. Your challenge: identify as many minutiae patterns as possible. Look for ridge endings, bifurcations, trifurcations, islands, spurs, anything we just talked about. Pause the video if you need to. Take your time and try to spot them. Once you're done, comment below how many have you found. Let's see who gets the most. Ready? Go. Alright, time's up. How many minutiae patterns did you spot? Did you get all of them? If yes, great job. If you missed a few, don't worry. Identifying minutiae patterns takes practice. But the more you train your eyes, the better you will get at spotting these crucial details, just like forensic scientists do. Now that we have understood minutiae patterns, let's move on to the classification of fingerprints. So far we have covered what fingerprints are, their types, and how we develop them, and also the minutiae patterns. Now let's move on one step closer to our main topic, fingerprint analysis. But before we dive into that, we need to understand how fingerprints are classified. Because without classification, fingerprint identification would be like finding a needle in a haystack. One of the most important systems used for fingerprint classification is Henry's 10-digit classification system. This method, developed by Sir Edward Henry in 1897, was a game changer in forensic science. Before automated databases like AFIS, fingerprint records had to be searched manually. Imagine going through thousands of fingerprint cards by hand. That's where Henry's system helped. It provided a way to categorize and organize fingerprints based on ridge patterns. So how does it work? It assigns a numerical value to its fingerprint based on its pattern. There are three main fingerprint patterns: loops, whorls, and arches. But wait, you might be wondering, what exactly are these patterns? Don't worry, in the next slide, I will break them down for you with images so you can get a clear visual understanding. Trust me, it will make things way easier to grasp. Using Henry's 10-digit classification, fingerprints could be systematically stored and easily retrieved. Before the digital era, this system was widely used by law enforcement agencies across the world to match fingerprints to criminal records. Now, why this is important? It brings order to chaos. Instead of randomly searching thousands of fingerprints, investigators can quickly narrow down their search. Also, it speeds up identification. If a suspect's fingerprint was already in the database, Henry's system offered officers find a match in minutes rather than days. Then it laid down the foundation for modern systems. Today's automated fingerprint identification system, AFIs, are built on the same principle as Henry's classification, except now computers do the hard work. Think of it this way: if AFIs is like Google for fingerprints, Henry's system was the first ever filing cabinet that made fingerprint searching possible. Without it, fingerprint analysis as we know today wouldn't exist. Alright, now let's talk about the three main fingerprint patterns: loops, whorls, and arches. They are the fundamental ridge patterns that forensic scientists use to classify fingerprints. First one is loop. Loops are the most commonly found fingerprint pattern, found in about 60 to 65% of people. In a loop, ridges enter from one side of the finger, curve around, and exit from the same side. Loops also have a core, the center of the pattern, and a delta, a triangular ridge formation. Then the second one are whorls. Whorls are found in 30 to 35% of people and have ridges that form a circular or spiral pattern. Unlike loops, whorls always have at least two deltas. Then the third one are arches. Arches are the rarest fingerprint pattern, found in only 5% of people. Unlike loops and whorls, arches don't have deltas or cores. Their ridge flows continuously from one side to the another in a smooth wave or a steep peak. Now that we have understood the basics, let's dive deeper into the subtypes in the next slide. So first, let's talk about loops. As I have already said, they are the most commonly found pattern. So its subtypes are radial loop and ulnar loop. So in radial loop, the ridges flow from the thumb, and in ulnar loop, the ridges flow toward the little finger. Pretty simple, right? So now let's move on. And then there are whorls. Now whorls, they are circular and spiral-like patterns. Its subtypes are, first one is plain whorl, a simple circular or spiral pattern with two deltas. Central pocket whorl. They look like a whorl but with one delta much closer to the center. Double loop whorl. Two loops combined forming an S shape. Accidental whorl. A mix of patterns that doesn't fit into any other category. Then the third ones are arches. Now arches are the simplest ones. There are only two subtypes of arches, plain arch and tented arch. In plain arch, it is a smooth and wave-like pattern. And in tented arch, this one has a sharp peak almost like a tent. And there is also a fourth type of pattern known as composite patterns. In composite patterns, first one is central pocket loop. It has a mix of loop and a hole. Twinned loop. In twin loop, it has two loops intertwined. Lateral pocket loop, a loop with a hole-like twist. And the last one is accidental, a completely random mix of patterns. Alright, now we're getting to the real deal, fingerprint analysis and examination. So how do forensic scientists analyze fingerprints? There are two main methods. First one is manual examination, where experts visually compare fingerprints. And then there are digital examination, where they use advanced softwares and databases like AFIS. First, let's talk about manual examination, which follows the ASV method, a step-by-step approach using fingerprint analysis. So A in ASV stands for analysis. First, the expert carefully examines the fingerprint. They check its clarity, reads details, and quality to determine if it is suitable for comparison. For example, if a fingerprint is too smudged or incomplete, it might not be usable. Then C stands for comparison. The unknown fingerprint is compared with a known fingerprint from a suspect or a database. Experts look for matching minutiae points, ridge flows, and patterns. For instance, two fingerprints are placed side by side, then the examiner checks if ridge endings, bifurcations, or any other minutiae points align. And then E stands for evaluation. A conclusion is drawn based on the degree of similarity between the two patterns. If enough minutiae points match, the expert determines whether they belong to the same person. If at least 8 to 10 minutiae points align, it is considered a strong match. Higher is always the better. Then V stands for verification. A second examiner independently reviews the findings to confirm accuracy and reliability. This step ensures that there are no errors, just like proofreading a document before finalizing it. So that's how manual fingerprint examination works. As we move forward, we will see how technology has made this process even faster and more precise. Now let's talk about digital examination using AFIS and NAFIS. So AFI stands for Automated Fingerprint Identification System. Imagine trying to manually compare a fingerprint against thousands or even millions of records. It would take forever. That's where AFIS comes in. It is a computerized system that scans, stores, and matches fingerprints in just seconds. For example, when a fingerprint is found at a crime scene, AFIS can quickly compare it with a massive database of known prints and suggest possible matches. And then NAFIS stands for National Automated Fingerprint Identification System. Now every country has its own version of AFIS to maintain fingerprints record at a national level. This is called NAFIS. It integrates forensic and law enforcement records, making identification even more efficient. For instance, if a suspect has been previously arrested, their fingerprint record in NAFIS can instantly have law enforcement link them to a new crime. While manual examination ensures accuracy through human expertise, digital systems like AFIS and NAFIS provide speed and efficiency, processing thousands of fingerprints in just seconds. This combination of human skill and technology makes modern forensic fingerprint analysis highly effective. Fun fact: do you know that India has its own version of AFIS? It's called FACTS. FACTS. It stands for Fingerprint Analysis and Criminal Tracing System. This National Automated Fingerprint Database helps law enforcement agencies store, match, and track fingerprints of criminals across the country. Instead of manually searching through records, FACTS quickly scans and compares fingerprints, making investigations much faster and more efficient. So we just talked about manual and digital fingerprint examination, including how systems like AFIS NAFIS, and FACS make identification faster and more efficient. But how exactly do forensic experts analyze fingerprints in detail? Well, that's where key analysis techniques comes in. First, we have ridge tracing and ridge counting. These help categorize and compare fingerprints. Ridge tracing follows the flow of ridges in holes, classifying them as inner, outer, or meeting, while ridge counting determines the number of ridges between 2 points in loops. These techniques help in systematic classification. Next, there's Minutiae mapping. This is where we focus on the unique ridge features like bifurcation, ridge endings, islands, and spurs. Since no two fingerprints have the same minutiae arrangement, this step is crucial in forensic investigations. Then we go even deeper with ridge edge analysis, which is known as edgeoscopy, and pore analysis, also known as poroscopy. Edgeoscopy looks at the shape and contour of ridge edges, while the poroscopy studies the size, shape, and position of the sweat pores. These microscopic details make fingerprints even more unique and are especially used when we only have partial prints to work with. Finally, we are moving on to one of the most challenging yet fascinating aspects of forensic science, that is collecting fingerprints from dead bodies. This is where forensic scientists push the limits of science to recover fingerprints, even in the most extreme conditions. Recovering prints from deceased individuals is not as straightforward as lifting a fingerprint off a glass. Factors like burning, decomposition, rigor mortis, or mutilation can make the process extremely difficult. But thanks to advanced forensic techniques, prints can still be restored and analyzed for identification. So let's start with arson cases. When a body is burnt due to fire or extreme heat, the skin gets damaged and the fingerprint ridges can become distorted. However, forensic scientists do not just give up that easily. They use techniques like cyanoacrylate fuming, magnetic powders, and iodine fuming to enhance any surviving ridge details. And what if the external skin is completely burned? In that cases, X-ray radiographs can sometimes detect underlying ridge patterns for identification. Next, we have decomposed bodies. As a body decomposes, the skin shrivels and loses clarity, making fingerprint collection difficult. But forensic scientists have a trick for that too. They soak the damaged skin in a 3% potassium hydroxide solution. This softens and restores the ridge to the original form, making it possible to take a clear print. And in cases where the outer skin is completely gone, the inner skin layers, dermal ridges, still holds the fingerprint pattern. By using transmitted or oblique lighting, forensic specialists can capture these hidden ridge details for identification. Third is rigor mortis cases. This happens when the body stiffens after death due to biochemical changes in the muscles. Now you can imagine how difficult it becomes to position the fingers for fingerprint collection. So what do forensic scientists do? If rigor mortis is in the early stages, they gently exercise the fingers to loosen the muscles. But in extreme cases where the stiffness is too severe, they may have to cut the tendons to allow movement. Once the fingers are properly positioned, the prints are taken using traditional inking methods or modern digital scanning techniques. And then lastly, we have mutilated bodies. In cases where fingerprints are damaged, missing, or severely mutilated, the fingerprint requires reconstruction techniques. Here's how it works. First, if the outer skin is destroyed, forensic experts check the inner skin layers, which still retain the fingerprint ridges. These can be carefully removed, treated, and photographed for analysis. And the second one is, if only partial prints are available, forensic software can be used to digitally enhance and reconstruct missing portions, making identification even more possible. Even in the most extreme cases, fingerprints refuse to be erased. and forensic science makes sure that they tell their story. It's a remarkable example of how science and determination come together to uncover the truth. So, to wrap things up, fingerprint analysis is one of the most powerful tools in forensic science. Its uniqueness and permanence make it highly reliable for identifying individuals in criminal investigations, also biometric security and digital forensics. With advancements in AI and machine learning, fingerprint matching is now faster and more precise than ever. Even in challenging cases, forensic experts continue to develop new techniques to recover prints, ensuring that justice is totally served. As technology evolves, fingerprint analysis will only get better, reinforcing its role in a key player in solving crimes and ensuring security. So here are the references I used to ensure accurate and reliable information. Feel free to check them out. And that's the end of this video. Thank you for watching. If you found this video informative, don't forget to like, share and subscribe to the channel for more exciting forensic content. Hit the bell icon so you never miss an update. See you in the next one. Bye bye.